How familiar are you with Java and intelligence?
And not like an object. When I was doing it, Java has been that.
All right. Well, I don't mean Java. I just need to figure out how to actually create.
All right, the live stream is up.
package.
We might need like a few more minutes to see if anyone else comes. But in the meantime, I guess I'll go ahead and let you guys know. So the president of the art club has reached out to us to try to see if we can do a Halloween event together. And I was currently discussing with him. He was thinking that we might try and do something on like the Wednesday of that week. So that's already when we have like one meeting for the particle systems. Would you guys have any objections to either combining that meeting with like a longer one with them, or just replacing that meeting with one of them?
I think either way.
I guess, does anyone have any sort of objections to either one?
Any last words? Speaking now, particle piece.
Yeah, because we can probably try and squeeze in the particle one somewhere else. We'll at least keep the GitHub one that's before that at least. That's the week before, if that's still good with you. I think next week. Because, yeah, it should be next week. Is that still all right?
Yeah, that's fine. They probably won't get long for it anymore.
Yeah.
Just a cool way to do things. And plus, I could probably use our game to show off stuff.
Oh, yeah, sure. But yeah, so I thought you guys would probably want to know that. I'll check on the live stream real quick to see if anyone's on there. Well, at least there's no messages. So, oh, I need to unmute that guy. All right, there we are. So I'll go ahead and get started with the tutorial. This will be, I guess, sort of long, at least in terms of the code we have to do, since it'll just be like one giant script to handle everything. So I'll go ahead and create a new project. 3D exploration game demo. And I'll just leave the render as forward plus and not really mess with anything else and just go ahead and create it. So what this tutorial will be about will mainly be trying to get the basic mechanics for like a 3D games, like your ordinary like moving, jumping, that sort of stuff, but also how you can interact with objects using notes. So like you can detect a raycast to see if you're looking at a note, use that to like read one. But then also you can instead of like say like reading a note, you can pick up an object, usually just bring it to you and move around and stuff. So that'll be the main thing we're trying to do with this tutorial. But to start off with, we're going to get our little level set up. So I'll just call it level. I'll name it here. And I'm going to go ahead and start with adding a mesh. I'll do a box mesh. And I believe I did it 25, 25, and 0.6. The Y doesn't really matter. You just need something there. You can always do a plane as well. I just find box meshes work a little bit better with collisions. So that's going to be like the floor for this level. I'm going to give a material so I at least have something to look at. So material, go on down to albedo. And I'm just going to give it some sort of color. It doesn't need to be anything in particular. Let's do like a green. And is there anyone that's following along right now?
Yeah, sorry, can you sort of like the options for the size of the plane?
Yeah, so I'll go back up here. So you said you had to see the size?
Yeah, I have to keep mesh selected.
Gotcha. So yeah, so if you click on that, it should show the size. So like, click on mesh.
Oh, I see.
Yeah.
And then 25,
Yeah. And then material, I did standard material and then clicked on that to expand that menu. And you get a bunch of options under the material. I just went ahead and just did the albedo just to give it a color. But you can always mess with a bunch of other stuff, maybe like trying to use some sort of texture or something. But I just kept it simple just for this. All right, you got it? All right. And then next, so we can actually interact with this guy, I'm going to go to mesh up in the top middle, collision shape. And then instead of sibling, I'm going to change that to static body child. I'm just going to do tri-mesh. So that'll give us a little static body we can interact with and a collider for it. So no need to mess around there. It's just all ready for us. And we can see if the blue line, well, where it is. So that's going to go ahead and be our floor. I'll rename that so I know what I'm looking at. Floor. All right, you got that floor? You want me to show real quick again?
Yeah, sorry.
Hey, that's no problem. So go to your mesh. You'll see this little mesh thing in the middle. You click on that, go to collision shape, then do static body child and try mesh and just do create. And there's a few options there. Like, yep. Would you like me to explain these options real quick?
Yeah, I guess we don't mind.
So over here is siblings. Like, let's say you made your static body or rigid body first, and you don't want to make like a new one on there. You just do sibling. That's what we'll do later on. We add on to rigid body, where the mesh will be a child of the rigid body. We'll take our mesh and make a sibling that's the collider for it. So that's why you have those options there. And then you have tri-mesh over here. So these are just the different ways to create your own meshes. Tri-mesh is usually the most accurate, but depending on how complex the shape is, you might not want to use it. And it's mostly good for static bodies. Then you have the convex ones, which really, I just kind of mess around with those until I get the shape I want. I think usually simplified convex is good for things that are more round. Multiple convex is good for things like with holes and stuff. And then single convex is just good generally when it's not too complicated. So that's generally how you have to look at those. And now the next thing we'll do is we'll add an environment. So we'll go to world environment as a node, create that, which should change your background a bit. And then on the right, you'll see environment, which is empty. We're just going to do new environment, then click on that. Then we're going to go to background. Instead of clear color, we're just going to do sky. And then that gives us a new menu called sky. We go to sky, then go to this empty sky here, do new sky, click on that. Then for sky material, we're just going to do procedural. And that's the very basic way to get like your sky going for there. I do that since if you don't do like an environment lighting or anything, it's going to look very weird when you start trying to put a camera in there. So you just need something else that's going to not look right. Do you need to run through that one more time, or you got it?
It doesn't start the environment doesn't start with like a built-in. Yeah, you have to create it first.
It's like there's something. I think it depends on how you do it. I know like oftentimes when I don't do this, it's like it's all like very grayscale, which doesn't look right. So that's why I usually start with this. I will say it's also fun to mess around with, since I believe if you just click on this guy, you can go mess around with your like procedural stuff, change like the colors and all that around. So it can get some very interesting effects. But we can leave that alone, but you can also mess with that by yourself. But this is our basic level we're going to work on. I'm going to save that for now. I'm going to start working on our player. So hang on, let me get this guy going. I'm going to go to Utter Node, then Character Body 3D. So I'm going to get a bunch of these set up real quick. I'm just going to call that player so I know what I'm working with. Add child node. We're going to do mesh. And then this is where the sibling thing is going to come in. Since I'm going to do for mesh, I'm going to do a capsule mesh. I'm just going to leave it as the standard one for now. But you can always mess around with it a bit just by clicking on it and messing with your like radius, height, and all that. We're doing your material, but since you're not really supposed to see this guy, you don't need to. But I don't even necessarily need to do a mesh. I could just go straight to Collider, but I find it easier to have this to look at when I'm working with things. So I'm going to use this, collision shape, and then I'm going to do sibling. I'm going to change this to simplified convex. And to see what that did, I'm going to hide this guy. So this is what the simplified convex does. It's definitely not as perfect as the tri-mesh. Because the tri-mesh will get like all the geometry correct. But that also means the collisions get very weird. It's a bunch of vertices it's going to be detecting all at once sometimes, which the game engine really does not like. So if you're doing anything round, I just suggest doing this. Anyway, next, going to add our camera. And that starts off in the middle. I don't really want it there. So I'm going to go and transform. Let's move it up a bit. Let's see. One's a bit too high. Let's try like 0.8. 0.8 seems fine. And if we go up here and scroll up, we'll see the camera view. If you just want to check that real quick. That seems okay. Now we're going to make a canvas layer. And then I'm going to do a VBox container. that switches it to 2D view, which is actually useful. I'm going to change this guy for its anchor up on the top. So the anchors you can find right next to the anchor icon up there to the left. I'm going to change it to, I believe this one has to be up down here. So do for that bottom center one. So it should be right here. And then I'm going to add another child of it. It's going to be a label. I'm going to add another label. I'm going to name these note label for the first one. And I think hold label for this one. So what this is going to be is this is going to be our UI for seeing if we can hold or like read something. So the note one is for like reading notes. The hold one is for like holding up an object. They'll just be like to say like press E to like pick up or press E to read, stuff like that. But we don't need to give them text. We'll just do all that based on code later. So the only thing I'm going to do is just turn off their visibility just for now, since we don't want them visible unless you're like looking at something that would let you. So that VBox is good. Next, we're going to do panel container. Hello. Do you follow along with the tutorial, or are you just more chilling?
More chilling.
Gotcha. So I'll go ahead and continue. So we're going to use a panel container for the next one. That's just so when we have our note, anything inside of it's going to have like a background to it. So we'll do that. And then we're just going to do label again. And just to keep this organized, I'm just going to call this note contents. And for this one, instead of putting it in the bottom center, I'm going to just put it in the center. And I'll turn off the visibility for that. Okay, I'll show you real quick where this should all be. So this note content, you should see it right in the middle here. Does it look like that on your end? All right. And all it needs is that label. Then I'll turn off the visibility. So from there, we'll go back to our camera, and we're going to add a raycast. And I believe for this one, we're going to turn, so we go to our target position here on the right after you add in the raycast. It should be on your camera. And we're going to change this Y to like just a 0, go over to our Z, and we're just going to make that -4. You can make it a bit shorter or longer depending on how you want the reach to be. I'm just keeping it 4 for like ease of use. So it might be easier to do like -2 or something as well. Anyway, so it's all the nodes we actually need on our player. So do you have all these guys down?
I think so.
All right. So I'll go ahead and add a player script. All right. Now this is the part that's going to take a little while since we have a fair bit of coding to do. You got the script? All right. So first off, we're going to declare a bunch of variables. Actually, do we even need health? I don't think we need health, so I'm just going to ignore health. But we do need speed. That's just going to be 3. Then jump velocity. We're going to make that 4. Push force. We're going to make that 2. Actually, you know what? We should make this guy float. Hang on. I realize it's better that way. And then these are ones that we're just going to use to keep track of some states we have. False. Holding equals false. When I get all these typed out, I'll explain them in a second. Just dropped equals false. Or just red is false. All right. So that's a fair bit of variables. We'll be using at least all of these guys. So to start off with your speed and jump velocity, those ones should sort of make sense. They're just for, well, keeping your actual movement like we did in 2D. Then you have push force. That's so that we can actually give it so when your player like hits like a rigid body, actually can move it. Because ordinarily your character bodies, they can't move anything by default because they're based on velocity, whereas rigid bodies are based on force. So you have to sort of in a way like convert like one to the other, which that push force will do. Then you have like reading, holding object, and those ones. Those are just sort of keep track of whether like we're reading something, if we're like holding an object, holding the holding object thing itself. That'll just be so we can save the object itself that we're referencing, and that way at any time we can just call that, change its position to where we want it, and stuff like that. Now there are certainly better ways to do it. This is just my quick way of doing it, but you should probably experiment by yourself to do some other ways. But the first thing we're going to do is we're going to do our little ready function, then input dot mouse mode plus input dot mouse mode captured. So what this does is that it's going to like hide the mouse and keep it centered, which is of course like we usually want for like some sort of first person game. Usually you put like a crosshair. We don't have a crosshair in this circumstance, but it should work okay without it. So that's all you need and you're ready for now. Then we're going to move on to our input function. It should be this guy. Yep. And then if event is input event, I believe it's mouse motion. Yeah. And this is going to be handling for like rotating our player and our camera based on our like mouse moving around. So this is going to take a second to get in there, but it should make sense when we're done. Up minus event relative dot x times 0.002. All right, so this first line here, it's going to take how your mouse is moving the x direction and rotate your player. So in vector3.up is sort of like your, well, it should just be your up direction. So it's like doing like a torque along that way. And then we have this little like 0.002 thing times that, because if you just did it directly from one to the other, you would be doing ridiculously fast. So you can always mess around with this. You can only get faster or slower, which would really just be your way of messing with mouse sensitivity in the game. But I'm just going to leave it like that. You can mess around with it to see what happens and hopefully not mess it up. So next up, we're going to do the same thing for our camera. Rotate. And then to make that easier, I'm just going to grab this bit of code here. We're going to change this from up to left. And then I think I get rid of the minus. Change that to Y. And there we go. So if you did not want to put any limits on your motion, this is all you would need to like move your character around when you like change your mouse. It also look up and down. But we're also going to want to put in some limits so that you can't like do your head all the way around like 360. That would be unhealthy. So we're just going to put in some basic limits for that. If camera dot rotation dot x is less than negative pi / 2, then I'm just going to grab this guy equal negative pi / 2. And then we're just basically going to take that same sort of thing. Instead of it's greater. Yeah. So this is basically just make it so you can always like look like 90 degrees up or 90 degrees down.
Would it be, so the rotation X is that the, oh, you're right, that's the.
Yeah. Let me move this guy so it's a little bit easier for you to see people anyone on the YouTube ask any questions yet?
No.
All right. Thank you for checking. So I'll go ahead and go to the physics function. So it's all we need for the camera movement and stuff. Now we're going to go to the bigger function, which is all the physics stuff. So first, we're going to turn a bunch of things to false whenever we go back through this. Just red equals false. Because those like just things are just so that we know like inside the function, we just change something around. We don't want to be trying to like do it again. I think if I calculate, the main idea is so like if you are looking at something and read it, you click E, it doesn't immediately try and drop it as well in the same frame.
Yeah.
Yeah. So. So that's at least how I did it with these ones. There's probably a better way though. If holding equals true, then if, wait, whoops, hold object equal null, holding equals false, hold null. All right. And then you have this little bit of code here. Should be defined. Did I?
Oh, that's cool.
Sorry, that's my bad. I meant to do hold object. I think, yeah. Yeah. So what this little code here should do is if it currently thinks it's holding something, but an object has actually like been deleted or some other thing, then it's going to immediately like revert that thing to false, and to make sure that thing is still null. Which theoretically you could just get rid of that, but I just do as little just in case things. You always have to be careful if something weird happens with your code. And then you've just dropped, you're going to change it to true, just so it's as if you just dropped the object, essentially. All right. But then if you're actually still holding that, even regardless, which actually, wait, hang on. Oh, wait, no. Okay, I know why. So I realize there's a better way to do this. I had this written in a bad way before. We're just going to do else, then hold obj. Global position equal camera 3D global position, and then I believe that's it. Minus 1.5 times camera 3D get global transform basis dot z. So that's a bit of a weird line of code. It's going to take your object that you're holding and set its global position to that of the camera, but then in the direction of like 1.5 times the way it's looking. So it's a bit of a weird way to do it, and there probably are other ways. That's just the way I found. Hold obj linear velocity vector 3. Then we're going to do 0, -1, 0, whoops, angular velocity 3, 0, 0. So this is just saying some like velocity for whatever object you're holding. Just a little bit of gravity, which you probably don't need that much, but it's just to help make it a little bit more realistic how it's moving. Then you have the angular velocity. You want it to be 0, otherwise it's going to be spinning all over the place. But you always change that around if you want to. I just find that a bit easier. And then let's see. If input dot is action just pressed. And I'm going to define one, but then we're going to start doing our input actions. So now we're going to go ahead and do a bunch of our input maps. Because we're going to start with use, but then we also have all of our movement ones. But I think that should be all the ones we need. So project settings, input map. Let's do use. Oh, whoops. Gotta make sure it's capitalized. Use E forward. Backward, left, right, jump. I believe this should be all the ones we need. So I'll leave this here for a second just so you can make sure you get them all. But use is going to be like used for both the reading and for holding up objects. If you want to, you can always define those separately. But I just define them as one big thing, since ideally you'd only be looking at one at a time and just switch between the two prompts you have for them. But if need be, you could do two different use things for it. All right, you got it? All right, so we're going to close that out. We'll continue for a little bit of coding. Holding equals false. And then hold object equals null, and just dropped equals true. There we go. So that's essentially just dropping the object whenever you press E to release it. So we'll go ahead to the next thing. If reading equals true, then this is where we're gonna do a bunch of our menu stuff now. So I'm gonna go down to, I believe it's note label. Yep. So I just use my arrow keys just to go down to it when I was typing it. I'm gonna do text equals press E to discard note. So basically, if you're reading it and you want to be able to discard the note, this will change that text to tell you that you can discard it. And I'm just going to grab this guy, take that, visible equals true. Then if input.is action just pressed use, then reading equals false. We're going to take this guy, I believe, right? Oh, actually, no, we're not going to do that guy. We have a different thing we need to turn off. I forgot. We're going to go to our, which one is it? There, note contents, visible equals false. Right. Yeah. And just read equals true. So that's just for discarding the note you had, and that'll also make sure it turns off the thing to show you what the note was. So that should be good there. And then if this one, we're going to go down to our raycast. So if that raycast is colliding and get collider So you could argue that these two things are doing the same thing. I've just found in practice it's sometimes easier to have both conditions there just to make absolutely sure you are looking at something you can get. But if need be, you probably could just use one of those just to get whatever your raycast is colliding with. And this is just a line just to make sure at least there is something. All right. So we got this. Let me make sure. If I do have this guy now, we'll grab that. Then dot is group. And we're going to do notes. Right. Yep. Then we're essentially just going to do what we did over here. Grab that. But instead it's going to be, instead of discard note, it's going to be read note. Should make sure that's true. And then we're going to make sure we detect if the player's trying to use it. Let me make sure I'm keeping track. And just read equals false. Oops. False. Reading equals true. Then go over here. Text equals. All right. Now this next thing we're going to do is going to be very funky looking, but I'll explain it. So we're going to go here. I'm going to grab that collider that we did before, so that we know what we're looking at. Then we're going to do get meta note dot replace. That's going to be that. Okay. So like I said, this is a very weird bit of read line, but I'm going to explain it bit by bit. So first it's going to grab that thing we're colliding with, that should be our note. It's going to go to its metadata, which is where we're going to put the note contents. You could do like a variable or something, but if you do with your metadata, on every instance you make, you can always edit your meta without messing with any variables and all the other ones. So I personally find it easier if you're just doing like a note, like some simple string or something. Just put in your metadata and make sure you call it a note, and then it's easy to get. And then this little replace thing is so you can have multiple lines to your note that work fine. Because as far as I can tell, when you have like a string, you can't like directly do a line break in there. But you could do like a /n inside of there, and then you use replace thing, and it'll replace the actual correct one. So that'll make sure you get actual line breaks in there. Does that make sense?
Yeah.
All right. Yeah, so like it's a weird way of doing it, but it does at least work. All right. So we're done with that crazy line. And I believe you can go down by 2. And I believe it's elif. If it's false, that's going to get our note label. And it's just going to set that to false. Yeah. There we go. And then we're just going to do the same sort of thing, but instead we're going to be checking if it's in the holdable thing. So holdable. And then I'm going to grab both of these, but instead of note, it's going to be hold. Hold. Press E. Pick object. There we go. And then same sort of thing here. I'm just going to grab some of these. So instead of reading, it's going to be holding. Instead of just read, it's going to be hold. And then, oh, why is it not like, oh, holding. I guess when I had something, what was it? Oh, just dropped. There we go. That was my bad. And then hold object. And we're going to set that to the guy we're colliding with. There we go. And then go down by 2. Else. Wait, hang on. Why am I? So I'm trying to make sure I have this all set up right. If it's in holding. Oh, oops, sorry. I forgot one line here. If holding equals false. There we go. We're just going to indent these guys one bit. There. All right. Sorry, did you also correct that like I did? I had to add this guy here and then indent this stuff. Got it? Yeah, sorry. It's a bit hard to read all this. It's very weird. I promise we're close to getting done with all the code stuff. Because we're just almost done with this craziness of all the reading and holding. And then once we're done with that, it's mostly just the basic movement stuff, which we kind of understand to do from the 2D. And then from there, just make our note and our objects. You got it?
Yeah. Instead of doing the full path to each node, you have a variable.
Yeah,
assigned.
you could. So like, that's definitely an option. Sometimes I do, other times I just get a little lazy and I just do it this way. Which technically, maybe it's not the lazy way. But I don't know. Sometimes I just find it easier to do it this way. But yeah, you can definitely just make a variable up top defined and just use that throughout. So let me see. So we're just going to change that text to drop object. And let's just set that to true just so you make sure you can always see that. Yep. And then else. And we're going to change that hold label visibility to false. Right. Yeah. what? So I'm trying to make sure. Okay, something in here is a little fishy. I thought I had this all done right. Let me see what's got a little fishy. There's one there. Let me see. Okay, sorry. Dang it. Okay, I need to do this a little better for next time. Nope. Okay, it's right here. Why is that so weird? If reading equals false, then I indent all that stuff. Right? Oh, okay. I could have just done it somewhere else. Okay, I'm sorry. I had that all laid out in a bad way for me to try and read it off here to make sure I got it. And elif, that one is going off of the notes. Yep, that's correct. Okay, yeah, okay. So that should have fixed the whole issue there. I was missing like an indent. That's why I was so confused. So go back down here. Else. Then we're going to go to our hold label. Visible equals false. Whoops, that's not a colon. If reading equals false, then let's go down to, I believe it's, what was it, note label? Yeah. Yeah, sorry. That is definitely a whole mess of stuff that's kind of weird to keep track of. I probably should do that a little bit better next time. But I mostly was just doing what I did for that Frost game, which it does work at least. I do know this works when you notes and holding objects, I swear. Yeah, I just had to correct like an indent somewhere a while back just to make sure I could get these guys in there. But does it look okay on your end?
Yeah.
All right. So at least we're done with that craziness. Now we're off to the stuff we are used to. If not is on floor, velocity, then plus equal, get gravity times delta. So because we're working in 3D instead of on 2D, I decided to use like actual get the gravity thing we have itself instead of messing around with that. So you always define on your project settings and stuff, that's the one it'll be taking, as good times delta, so it's consistent across the frames.
Yeah, that's the time between each frame.
Yeah. So that is usually the way you should actually be doing it. Just sometimes I find it easier not to include it, which could be weird if you're, well, trying to make a proper game that works on every one person's machine correctly.
Because, low advocates.
Yeah. So we have that. And then next, we're going to go to if input dot is action just pressed, jump, and is on floor, velocity dot y equal jump velocity. Then we're going to do a different way to get our input directions than we've usually done. This is sort of how they used to have it inbuilt in Godot, but for whatever reason they kind of stopped including it all the time. You get vector, and then we're going to do left, right, then forward, and then backward, or direction, transform dot basis, Let me make sure I got that right. Dot y. Yep. Dot normalized. Okay. So this is the way we're going to get our direction compared to what we've usually done. So usually it's like we directly take those inputs and then we just like apply like a velocity or something in those directions. But this is a way to do it where it's more like a vector you're getting that's all normalized. So there is no weird like, okay, you're pressing left and like front at the same time, it's going to do like extra in that direction. This gets rid of that whole issue. So it basically gets a vector from all those values and like the x and y directions, then normalizes that. So this is telling you the better way to do it, but depends if you really want to do it. Sometimes you don't really need to. Then velocity dot x equal direction dot x times speed. And we're just going to grab that. Else, we're going to grab these guys. Oh, actually, sorry, my bad. I got that wrong. Move toward velocity.x, 0, speed. Same thing here. Okay. And what these ones are doing is sort of like, if you're not pressing the move, it basically slows you down in that, like over time, essentially. So it's sort of like what I used to do for that friction stuff, just maybe a little bit easier. So that's just another way to do all that.
If the direction uses like the direction variable uses like the x and like left and right for the x movements and up and w and s for the z movements. Would the velocity be like velocity dot z?
It might be right now, so I might just mistype that. Yeah, you're right. My bad. We probably don't want to be going up when we're trying to go to the side. Definitely a good point. All right, there we go. So problem solved there.
I was also just, I was wondering like, is there? I was wondering what ties for instance, the left and right input. So like you name the input left and right.
Yeah.
And the forward and backward. I was wondering what ties that to input direction or if that's just like
It's just directly taking it from those actions. Like you see like it pops up, it just like takes those actions. I believe it's like some sort of like 0 or 1 essentially. I think it's how these are supposed to work.
but like when you named it forward and backward, like on that, technically that's supposed to be.
Okay. Yeah. It usually should do all that for you. That's definitely a nice helpful thing. And if it doesn't do that, sometimes it's a sign that they're not named right somewhere, and you might want to check that. So next, we're going to do our move and slide. And then we're almost done with this big script. The last thing we need to do is make sure our player can actually push things. But that's not too hard. So I'll show that real quick. Get collision. Slide collision count, right? Yep. So we're going to loop through all our collisions. C equals get slide collision, I believe. Yep. I. And then if C dot get collider is rigid body 3D. Get collider dot apply central impulse negative C dot get normal times push force. All right. So basically, this is going to loop through everything that we're colliding with. It's going to get like whatever it is colliding with, and that's going to get that collider to see that's a rigid body because we don't want to mess over static bodies. And it's going to go to that. It's going to apply like an impulse for like a force. It's basically going to hit the normal you have to and like push in that direction essentially. Does that make sense?
Yeah.
All right. And that's finally all the code we're doing for our player. So it took a while, but that player is actually finally done. Which this is the hard part of all this. Now it's just getting in our basic objects. So I'm going to go over here, other node. I'm going to do a rigid body. I'm going to switch to 3D to make it easier. I think we're going to call this note. Then I'm going to do a mesh. And I'm going to go over here. I'm going to do a box mesh. To make it sort of note-like, I'm going to keep 1, 1, and then actually I'm going to do 0.15. This should work. Hopefully it doesn't fall through the floor if it's too small. It should be fine on this size. Then I'm going to do collision shape. Then I believe simplified convex should be fine. Let me make sure what that looks like. Okay, I don't like that shape. So I'm going to delete that. And let's see. So this is a relatively simple shape. Tri-mesh will be fine. It does get angry because it's like, hey, that's probably not the best idea for a rigid body, but it's relatively okay. It's more collisions than you necessarily usually want, but because it's just a box, it's not too bad. So I'm going to keep it as a tri-mesh.
And the collision shape is sibling,
Yep, sibling.
and the type was.
I did tri-mesh this time, but you can always just mess around with that yourself. It'll always give you something that works, but I just find tri-mesh in this case is a little bit easier. Then we're going to go back to my note. I'm first going to go to node, go to groups, and I'm going to call it notes. So that should be on the note itself. You go to inspector. We're going to go down to our metadata. We're going to call it, I believe, a note. And then I'm going to make it a string. So I'm going to give you a second just to make sure. So do you have the group?
No, I got lost in the
All right, no problem. Let me go back. So you go over to your node, like the note, go to the node, go to your groups and make a notes one. And make sure you have the same capitalization as you did it before for when you were doing the group stuff before. Then we're going to go back to inspector. Then we're going to go down to add metadata. Click on that. Change your type to string. I'm just going to call it note. I believe that should work. So that's all you need to do there. We're going to add that. Then now you have that little box down there in your metadata, like note, this little text box. Just put something in there to test. Here you test note. I did the \n just so I can make sure the replace thing is working correctly, but that's up to you if you want to do it that way. Then that's all I need to do for my note. Here, save that. You have it.
Yeah.
All right. And then we're just going to go ahead and make something just to mess around with as a rigid body. So rigid body. I'm just going to make this like a barrel, but you can always make it something else like a crate, a cube, something else. So mesh. I'm going to go and make this say cylinder. I want it to be like a little bit smaller. Let's say like on like 1.5. That's a bit small compared to our player. Let's make like 0.8. Then 0.2. 0.2. There we go. We're going to give it some sort of material. That's not necessary either, but I like having a material so I know what I'm looking at. So let's just mess around here. There we go. It's like sort of like a reddish color. Create a collision shape. This time we make a collision shape. If you're doing a cylinder or something round like I did, don't do a tri-mesh. It would not be nice. Just do a simplified convex. And then you'll see again like how it's not necessarily very accurate to the whole shape, but it gives you a better geometry for collisions at least. But even then, honestly, I might even do a different type of convex, but this should work better than tri-mesh at least. That's all you need to do there for the collisions. Then we're just going to go to our node, and we're just going to put holdable. So for anything you want the player to be able to hold, just put in that group, and that should be all you need to do. So we're going to call that barrel. All right. You got your object? All right. We're going to go back to our test level. And instead of like copy and pasting them, I'm just going to drag them on. So I'm going to drag my player. I'm going to go drag a barrel over here, maybe another one over there. Then a note right here. The note's kind of big, but we'll deal with that. Now I'll just make it so it's a little bit higher so we can see that it falls. So hopefully this one does not fall through the floor. With all that's done, this should work. So I'm going to load that current scene. Oh, okay, yeah, that note did not like the size I gave it. I'll fix that in just a second. But we can hold these barrels. They work just fine. I'm going to do F8 to get out of that. And yeah, unfortunately, like I thought, the note, it did not like something there. Actually, oh, hey, I know another way you can fix that. If we go to our floor, go to static body, actually, no, the collision shape, we can go to here, to our shape of that collision shape and do backface detection. I think that might fix the problem. Let's see. With thin objects like that, it gets a little bit weird in trying to fix them. So let me go back here. Oh, function 8. Yeah. That work? Sorry, I hadn't realized they had different things for Mac when it came to that. Keyboard. Hang on. Wait, let's see. It says command and period. All right, nice. That is much different than what I'm used to for Windows. I don't know why. But yeah, so I'm doing a few things to try and make this guy work a little bit better. For instance, we can change the solver for our notes rigid body. You go to your rigid body, go to solver. We do continuous CD. That's like for collision detection. We go back to our test level. That might be what fixes it. Otherwise, we might just need a bigger note. Okay, we just might need a bigger note for now. It gets weird sometimes. So I'm just going to go to here, get rid of the collision shape I have right now. I'm going to make this guy, let's say 0.4. I'm going to make another one of these. Try mesh. There we go. Go back here. Okay, no, maybe it just does not like try mesh. It does not like thin objects. I'll just say that. There are ways around it. It could just be making your floor much thicker sometimes as well helps. But just for testing, I'm just going to make this a very thick note. I'll change it to single convex. Maybe that fixes that. There we go. So yeah, so sometimes thin objects, it does not like having to deal with their detection, so you have to mess around there for what dimensions either work. Maybe you have to change the collider up or something. So it gets a little bit weird, but there are ways around it. Anyway, oh, why did it not like that? String. Oh, I see why. Because that wasn't the wrong thing. Slash. Hang on, let me go back here. Label. All right. So I had to go to the code. It gave me an error when I went to go read it because if you go to, I believe it should be line 55 in yours, you have to add that label right here to this guy. Yep.
Yeah, web rotation is very, very interesting.
All right, so let's see real quick just to make sure that actually fixed that issue. Yep, okay. So we can see our little note there. We can discard it. We can go to like little things, pick them up, move them around. We can push them around. So that's just the basic mechanics you would need for a 30 exploration game, probably something like physics puzzles, maybe notes like explain stories, stuff like that. Does that all make sense?
Yeah.
All right. So there are definitely better ways to do that whole note system. That's just the way I've done it in the past. There would probably be like a limited state machine or something as well to make it easier.
Yeah.
Yeah, so that's it for that actual tutorial. I'll go ahead and check on the YouTube to see if anyone ever actually joined on there. I don't see anyone, so I'll go ahead and end the stream.